All right. So we talked about primary pollutants yesterday, and we defined secondary pollutants. And this diagram will give you a better overview of what that really means. So here are natural sources like volcanoes. What's another natural source of air pollution? Fire, decomposition, right? Anything that happens naturally that can produce chemicals into the atmosphere that could end up causing harm are considered primary pollutants. This would be mobile sources like cars. What are other mobile sources? Trains, planes, right? And then we've got this stationary. What's this an example of? Factory, industry, power plants, right? Electric power plants. So they produce these primary pollutants, which are all there for you. Carbon monoxide, carbon dioxide, sulfur oxides, nitrous oxides, volatile organic compounds, and particulate matter. When those react, there's other primary pollutants, by the way. I'm going to give you them as we talk. I'm also going to tell you whether they're natural or they're man-caused or even man-made, because some chemicals are literally produced in the lab or compounds are produced in the lab and end up causing harm. And then if they mix with any other compound in the atmosphere, so any reaction that takes place from a primary pollutant with another compound forms secondary. And these that I've underlined here, we're going to talk about today, okay? I will always tell you from here on out, if the pollutant is primary, if it's directly emitted, is it natural, is it human activities, or man-made, okay? And if it's a secondary pollutant. So this is the first secondary pollutant we're going to talk about. So ozone is not primary. It's emitted into the atmosphere, but it forms through a reaction in our atmosphere, okay? Because we know what's 21% of our atmosphere? Oxygen, right? So somehow it's going to find another oxygen and form ozone, okay? What do we know about ozone up until this point without looking at this diagram or this slide? That it's in the stratosphere. We talked about it. What does it do in the stratosphere? It protects us from UV radiation that comes down. Whoops, wrong one. UV radiation that comes down from the sun. We call this good ozone. That's all you've learned to now. What you didn't know is ozone, obviously, since it forms, it starts in the troposphere. And in the troposphere, it's toxic. It's what we call bad ozone. And it leads to respiratory issues, damages crops, and also leads to photochemical smog, which I'm going to talk about today. So like every compound, remember I kind of start with what it looks like. Can you taste it? Ozone actually has smell, okay? So it's colorless, so you really can't see it, but you could kind of smell it. Well, you could smell it a lot. Like what other compound has smell? Sulfur. Sulfur, good. Other things I want you to remember today. If I mention the word immune system or major organ malfunction, what compound are you supposed to think of? No. But true, particulate matter is a primary pollutant. Not a compound, but it is a pollutant. What? Good. Hydrocarbons, which are called what? Volatile organic compounds. Okay? So you see the word immune system, major organ function, volatile organic compounds. What if I tell you hemoglobin? You think red blood cells and you think of oxygen, but you think of what compound? Carbon monoxide, which also can lead to death, okay? Every other one, think of respiratory issues, okay? Or irritation of the nose, eyes, things like that. Before we talk about secondary pollutants or problems within our environment from primary and secondary pollutants forming, I want to talk about things that happen naturally or in our environment that can decrease air pollution. Okay, so if you look at these pictures, see if you could give me any of the answers. Or without looking, if you know there's compounds in the atmosphere or particles which can cause pollution, how can they be taken away or taken apart? Particles heavier than the air, what's going to happen to it? It's going to go to the ground. So it's no longer air pollution. It's still a problem. It's just not in our atmosphere. What else can take air or compounds in the atmosphere away? Water. The rainfall. You know, water is a universal solvent, and oceans or sea spray will wash away or dilute particles, right? What else? What else can dilute or break apart a particle? Wind. Good. And what constantly happens to molecules? What are they always doing? Transforming or reacting. So any chemical reaction can remove pollution. Good job.
Happy birthday to Riley Arango Army. It's a big day.
Happy birthday, Riley. All right. Factors that increase or like form, because I want you to add the word form, pollution in specific areas, okay? Because these slides, they don't only focus on increase, they cause on actually forming, all right? So what can increase air pollution? Urbanization. Really, it's the tall buildings, right? Within. So tall structures trap pollutants, which kind of can lead you to the answer of the next picture. Mountains and hills. Good. So this would be what? Slows wind. It's slow wind, which can what? Decrease. Good job. Dilution or chemical reactions. Slow winds. It should say, not slows winds. These are a little bit harder. What does this picture show you? Temperatures doing what? Rising. So you would think, because this is why it gets a little complicated, increasing temperatures spreads apart molecules, right? So that would kind of dilute pollution, but there's certain things when temperatures rise in our atmosphere or certain ways that can trap pollutants. So I want you to know that high temperatures can promote a chemical reaction which causes smog, okay? Volatile organic compounds, where do they come from? Say the word. Volatile organic compounds. So where do they come from? What? Like living things, organic materials such as trees, okay? So I told you volatile organic compounds come from cars. They're found in solvents. Those would be the non-living things, right? Because, well, cars have gas, which will come from fossil fuels. But living things produce volatile organic compounds. Oak is a living tree, right? Kudzu, in parentheses, I want you to put invasive species. They produce excess amount of volatile organic compounds, and this also contributes to smog. So smog is obviously a problem. Then we've got temperature inversions, which basically, actually, I'll leave this one for last. They push down and trap pollutants, and I'm going to explain this first. And then this basically is an explanation which would say it causes pollution to start in a different area because it's somehow pollutants can get transported based on temperature to a different region. So the pollution should not be there because there's no contributing factor, no area, no mobile, no stationary that would produce it, but somehow it makes it there. So it causes pollution in that area. So somebody asked, can pollution travel the other way? Yes, but this vocabulary word, grasshopper effect, is really the transport of pollutants from tropical areas or temperate areas, which means what? Warmer climates to polar, which means colder, okay? Because that's usually the direction they flow anyway. The other way would be kind of inverted, which is what happens with temperature inversion. So I'm going to show you. This, you don't have this slide. This little picture here, I just made it bigger. Feel free to take a picture or add it or just look at it. Normal troposphere temperature is warm towards the ground, then cooler, then colder. I mean, the city itself, the more urbanized you are, the warmer the bottom is anyway. So it's warm, cooler, cold, right? In a temperature inversion, the cold air is below the layer of warm air. And because the pollutants would rise from hot to cold, let's say, right? Like energy does, like anything does, it's a natural flow. They end up turning, so those gray arrows will represent compounds or pollution. And they end up getting trapped here because they don't know where to go. So they create a layer which is called smog. This is a natural occurrence of smog when temperature inversions occur. I'm going to talk to you about a different smog which happens because of urbanization or cars. But whenever warm air gets trapped above cooler air, pollutants get trapped and they form a layer of what you could call smoke fog, right? Dirty fog is smog. So I'm going to talk to you about 4 major problems in our atmosphere, global major problems that are really mainly caused due to human activity, okay? What are they? Name them for me. Smog. Global warming. If you can't decipher the pictures, think of air pollution problems you know of. Acid rain. And it's true, but that would be like a temperature inversion. Good job. Depletion of the ozone layer. Big problem. So smog can form from temperature inversions because pollutants get trapped. Photochemical smog is smog, but it's caused by a reaction that starts with cars, okay, and the emissions from cars. Same concept though. It's where you have that haze over, and usually happens in a city during traffic hours, that is a big layer of pollution and reduces visibility. And when it gets so big, the problem, you can't even go outside without a mask, okay, because it causes respiratory issues. So for this reaction, I'm going to give you a diagram view. I'm going to go over the bullets, and then I'm going to form a sentence for you, okay? So cars, what are they emitting in this diagram? Volatile organic compounds and? Nope, look at the diagram. But yes, cars emit carbon monoxide from their exhaust. Cars emit every primary pollutant. So if you want to remember what causes a primary pollutant to go into the atmosphere, think cars, because they do it all, okay? But in this reaction, we're dealing with volatile organic compounds and nitrous oxides. Remember that all you have to do is remember the word nitrous oxides. What do these compounds react with? Look at the diagram. No, they form ozone. What do they react with? The sun. So volatile organic compounds or nitrous oxides, and it should be or. It could be and, but no, it is and. I'm sorry, it's and. Volatile organic compounds and nitrous oxides react with the sun, and they form the secondary pollutant, which is what? What's this? Ozone. Which then forms what's called PANs. And all you have to know about PANs is that they are a nitrogen-based compound that's associated with photochemical smog. So where China has a big problem with smog, so did LA. I mean, so big they literally attacked this issue because there was periods of no visibility, especially during high traffic times. They would even monitor school and illnesses, and there was a big link to illnesses because of this. All right, acid deposition, the last global problem we're going to talk about today, which you reference it, or AKA acid rain. The reason we call it acid deposition is because, or a better way to define it is precipitation, acidic precipitation, and solid particles of acid that come down from the atmosphere. We know precipitation is rain, hail, sleet, snow. So acid particles can come down in droplets of water, in snow, in hail, but they can also come down in particulate matter or solid particles and be acidic. When something comes down from the atmosphere, where's it going to land? In the ground or water, okay? So that's going to immediately affect ground or water with high levels of acid concentration. And this is how it happens. What primary pollutants are linked to acid deposition? You should know this. Nitrates or nitrous oxides and? Nope. Sulfur oxides. When those react with, what are we reacting with? Look at the picture. What is this? A cloud that's filled with water. They're going to form what? When nitric oxides react with water, what do they form? If you put an H in front of a nitrate, what is it? Hydrocarbon. There's no C there. H in front of nitrate. In chemistry, when you put an H in front of a compound, what does it form? This would be sulfuric acid. This would be nitric acid. Good job.